On guest.
That's also something that Apple version offers, but only with like press
Is the password correct for this? Is it on cloud 2022? Yes, that doesn't work. Ah, I'm on the wrong Wi-Fi, sorry. Bist du im Dings, Micha?
Den Screen kann man schon mal sehen, aber der Sound ist noch nicht da. Es ist nein, ist noch nicht als Szene angelegt.
Über was streamt er jetzt auf?
Noch gar nichts.
Ja, aber nachher. Übers Wi-Fi oder nicht übers Wi-Fi?
Das ist die Frage, warum?
Das Wi-Fi scheiße ist.
Normalerweise tun wir immer über unser eigenes Internet.
Das macht auch Sinn.
I actually started using GraphQL a long time ago, and then I even tried to make a startup in the GraphQL ecosystem, but it failed, more or less. It was about handling the attack problems like overly complex queries, how do you protect against those? Like there's these different approaches, like complexity, query complexity analysis, right? And there's a few others. There's like another one. It's like a template. Okay, so this is from it for. But audio is here, GraphQL. Then all of a sudden my budget is like.
Hallo, 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 hallo. Hallo, 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 hallo.
Nee, das ist der hier.
Hallo, hallo, hallo. Ja, mach mal Output.
Ja, warte mal. Das ist gerade Wave, ja.
Hallo, hallo,
Ja.
hallo. Mach mal Output. Aha, das kannst du jetzt nicht. Du gehst jetzt über Dings aus HDMI.
Pascal, sag mal was.
Hallo, hallo. Ja, aber es ist bei uns nur auf dem Tisch.
Ach so.
Juhu!
Ja.
Check 1, 2, 3. Hello, hello.
Ja, ja.
event together with Synda, together with Pierre-Michel, together with Alexander.
Conference that we as the foundation will do. It's in San Francisco. If you would plan a holiday on company costs, this might be a good location to go. Next year there will also be one in Europe. So just that you know, sometimes people are unaware. Okay, what is the GraphQL Zurich user group? It's basically a group for GraphQL nerds so that we can connect. And by the way, when you came in, there was a Felfel fridge. We had a meetup at Felfel, and these fridges also use GraphQL, just if you didn't know. So just fun fact how GraphQL really is encroaching our real world life throughout things that you didn't know that they were running with GraphQL. Okay, so we want to bring the GraphQL community in Zurich together, basically put you all in a room to chat with each other, share knowledge, and and bring people together. So how does these events work? We basically try to go to a new location every time for every meetup. So if you have a company that is doing GraphQL or you plan to do GraphQL, just give us a call and we come to you if you want to host us. That would be great. Each event has 3 talks, and each of these talks is 25 minutes plus 5-minute Q&A, so it's not so sometimes if you ask people to talk on an event, they think about 60 minutes talking. No, it's not so dangerous, our talks. It's more like lightning talks. And that's the right amount of time to give you an overview over a topic. So if you want to talk as well, come grab one of the organizers from us here, Rafi. There's also Jose, and somewhere is Pascal. So just talk to us, and we'll set you up. Yeah, and that's basically host an event if you can. Get your boss to host one of these events and tell others about it. So the next event is in September. We do a little summer pause because I know many people in Zurich. They are out of Zurich over the next 2 months, somewhere nicer maybe, I don't know. But in September, we will restart the events on a monthly basis. The first one is Education First. I didn't know them in the beginning, but they are quite huge. And I'm happy that we will learn all about Education First in September. Okay, and with that, I'm already done with the introduction. And I'm inviting here Synda to stage, and she will talk together with her colleague Pierre about migrating from schema stitching to GraphQL Federation. Okay, let's go. Your microphone, did you switch it on?
Is it on?
Yes, it's on. That's good. And I switch mine off.
But I don't see anything on the screen. Is that okay?
One second. Oh, it's because, yeah, go back into full screen. That's because I undocked you, probably. Yeah, there. You're on. Back.
Okay, so now I don't see the thing. Or start again? Can I start again?
Yeah, I messed up a setup, so.
Sorry about this, guys. If I can see. Oh.
Yeah, slideshow. There should be.
Okay. No way. That wasn't the rule.
Yeah, undock it there. Just do the green button. There. Up there. So go up.
Yes, that's not
Should I quickly do it? Or you get it? There. This green button. Because that undocks it and you can drag it over.
Okay.
Yeah, and then.
I think now it works. No.
Yeah, now you can drag.
Okay.
Did you get it? Just move it down the window.
Still not.
Where's your pointer?
Now start again. Is that
No, it's
recording
because
already
it's behind this window now.
Okay.
Just drag the window down. Yeah, there it is. You can see it. Just go in there. Yes.
Okay, thank you.
Sorry.
It's okay.
And now you can maximize it again on the green button.
If I can see my.
If you wiggle it, then
Yeah.
there. Sorry for that.
It's okay. We can start. Yes, I'm here. Hi everyone. Hope you hear me very well on the microphone. Yes, perfect. So we are very happy to host this event with the GraphQL Zurich meetup here. I'm Synda. I'm a technical lead at the global platform team here at ON. The platform team is responsible of doing all the cool stuff. We're doing all the SRE part, the infrastructure, also other things doing cool stuff, I see you. And yes, we're also taking care of the GraphQL gateway that we are having. And today we will be talking about our experience as an engineer, the way we moved from the monolith architecture to the decoupled architecture, and the journey how we moved from the stitching schema to the federation schema. So Pierre-Michel and myself, we will be doing this presentation in 2 steps. The first step will be focusing on mainly on stitching schema, and after that we will moving to the federation. So before starting digging a bit about GraphQL Gateway, let me tell you a bit more about ON, to not be confused to QC, of course. It's a Swiss company that was founded by very passionate athletes. They're passionate about running and shoes, of course. So we are known for as running shoes in the beginning, but now we are moving more and more, and we are open to different sports. And thanks to Roger and Igor, we are more known in the tennis playground, but we are also known as a lifestyle shoes. It's very nice to wear them every day at work. But behind the scene of the shoes engineers, there is developers, software engineers, front-end, back-end engineers. They are working on different technology and frameworks that you recognize some of the logos in here. So today we will be focusing on this logo, and this is how our journey will start. So I will be introducing the part about stitching, so the introduction what's schema stitching, so we'll have the same amount of idea. The GraphQL gateway architecture that we have it right now, and the challenges and the issue that we face it after deploying this GraphQL gateway. So what is schema stitching? So I know all of you know already what schema stitching, but yeah, let me make a bit of an introduction about it. So schema something that was integrated easily to our backend setup. And especially in the third part, the integration with external APIs. One of the things as you can, maybe some of you recognize the Contentful logo. So we use Contentful, and the fact that we like about connecting our gateway to the Contentful, that in the Contentful we can have the auto-generated schema that based on the content model, which is easily designed and auto-generated, which makes it easier to work with it. And especially we don't need back-end developers to map all these fields. So it was an easy choice for us as well. But we will talk about this choice after a moment. But then after the integration, I'm sorry to switch also directly to the problem and issues, we had faced some issue actually. One of the main, I think, issue that we had, it's about the fact that we had a complicated orchestration in our front end. So if we have to get a block of structure, we need to get information from the dynamic yields, and then to call a block ID, and then to go get the information from Contentful. So the front end was already knowing too much, and it was very smart, which is make it hard to orchestrate in the future. The second thing that we face was also the fact that we are using this dynamic schema. As I mentioned earlier, one of the choice why we choose the stitching is that the fact that one of our third-party choices auto-generates the schema itself. So it was helpful for us to have this type of setup. But in the meanwhile, that idea wasn't that good because each time we have some changes that are not approved by PRs or something like this, could bring break-in changes at our codes and, of course, incidents that were not that happened to us sadly a few times. So yeah, the dynamic schema was a good solution at a certain point, but not that a good solution. And we faced other actually issues that are not really necessarily strictly connected to stitching itself, but the way our setup was done, the testability, the fact that testing on different environments was really hard. And as well, we had some instability on the gateway. What we call the stability is usually to the troubleshooting when we have incidents. We didn't have enough information. Sometimes we have these null errors on requests, and especially it happened during a spike of traffic, which was very problematic for us. So this setup didn't work that much as we want and didn't scale as we wanted. So to move away from this, we decided to look for other solution, and one of them was to use the federation part. So I'm passing to our federation guy, Pierre-Michel.
So hopefully the microphone will work. So hello everyone, my name is Pierre-Michel. I'm a full stack engineer here at On, working in the platform team together with Synda. I'm mostly working with Node.js and TypeScript, and I'm here to talk about GraphQL Federation. So first I will give a brief introduction to GraphQL Federation. And in case you're wondering what's the difference between GraphQL Federation and GraphQL Federation, it's pretty simple. GraphQL Federation is the architecture pattern, and we chose GraphQL Federation to implement it, but there are other providers like Azura or the Guild, for instance. Second, I will talk about how to improve our current architecture, then the migration plan in 3 milestones, and where do we stand now. So what is GraphQL Federation? It's basically just a way to build queries with fields populated from different services. And those services are called subgraphs in GraphQL Federation. Now you might be wondering why the description sounds like the one we used for schema stitching earlier, and the reason is simple. GraphQL Federation is basically just a subcategory of schema stitching, a more specific way of implementing it, but at the end you're still doing schema stitching. But let's look at the example on the screen to make it a bit clearer. So here we have 2 subgraphs, so user and purchase. The user subgraph defines a user type, a pretty common one, so email, first name, last name. Then we have a purchase subgraph that extends this user type with a regular order and a subscription order, which is basically the content of the cart. And we tie it to the user to allow them to retrieve their cart when they log in using a different device. Next thing you need to implement with GraphQL Federation is a reference resolver. You need to define it in each subgraph. Here I'm using JavaScript for simplicity, but you can implement the subgraph using the language of your choice. It really doesn't matter. So I will come back to this code snippet later, but let's first look at how the query would look like. So here we have current user query, which is basically retrieving the current logged in user with a token. It asks fields from both subgraphs. And if we look at the query plan, which is basically just the way Apollo Federation is resolving the query, it will first send it to the user subgraph as it would be a normal GraphQL API. So using the query resolver of current user, will resolve email, first name, last name, and send this user object to the purchase subgraph. And if we look at the resolvers of the purchase subgraph, so you have the reference resolver, which is basically just the way you define the parent object, which would be undefined otherwise because it's coming from a different subgraph. So here we just simply pass the user object so that we can access it from the regular order resolver, for instance, which will just fetch the order by the user ID. One thing that is great to notice here is that the purchase subgraph doesn't have any dependency on the user subgraph. It doesn't have to re-authenticate the user because it's not its responsibility. Basically, the user subgraph, if we provide an invalid token, for instance, it will simply return null and will never reach the purchase subgraph. So this is actually a very, I would say, the most powerful feature of Apollo Federation, that the subgraph don't have dependency with each other. If we look at a more complex example, let's say that on want to launch a running app, which is not the case, by the way, but let's imagine it. So here we would have a running group query that retrieved a group by its ID. So again, looking at the query plan, it will send first to the social subgraph as it would be a normal GraphQL API, again, resolving name created at members and the stats for each members, and we'll send the user object to the user subgraph. And basically, if you notice, in the previous example, the reference resolver was only used in the purchase subgraph, but we basically need to define it in each subgraph that use this user type, because you never know in which direction Apollo Federation will resolve the query. So in that direction, for instance, then you will use the reference resolver of the user subgraph. But if we look at the actual code of that resolver, here we only need the reference resolver, because basically it will fetch the user object from the database using the user ID. And then since it's the parent object, it will resolve email, first name, last name automatically. If I come back to the query, there is something very important to notice here, is the fact that the reference resolver is resolving one single entry. So it means that, because like here, you're asking for an array of members, so multiple members, which means you will end up sending a database query for each single user, which is obviously not optimal. So in that case, I would strongly recommend using a data loader, which is a pretty common pattern in JavaScript, but again, also in other languages, which is basically batching the query. I won't go into too much details regarding data loader, but if you want more details, you just you can check the Apollo documentation or simply Google it. Now, how to improve our current architecture. First point is stop feeding the beast. The beast refers to our legacy API here. basically because our current architecture only talks to 3 different services. So we end up basically adding new features to legacy API, which makes it very hard to deprecate. And the second point is stop talking to third-party APIs directly, because at the moment, basically the front end is tightly coupled to Contentful, to the way it auto-generates the schema. And also, I mean, like Synda mentioned earlier, a change in the UI to a content model can basically break production. So it makes it pretty fragile. So the solution here would be to put microservices in the middle to basically talk to those services. So if we look at the principles of microservices by Sam Newman, I think 2 of them are mostly important to do the domain split and choose where you should define your different subgraph. So model around business domains. Let's take the purchase subgraph as an example again, taking care of the purchase journey. And it would hide the implementation details. So first, let's say would talk to our legacy API that currently holds all the e-commerce logic. But at some point, we would love to switch to a different e-commerce vendor. So having this middleman would allow us to do it in a much more straightforward way. But how does Apollo Federation comes to play? Because you can implement the microservice architecture without it. But like I mentioned earlier, one of the biggest benefits of using Federation is that you end up with no more dependencies between the subgraph. So you don't have to maintain API clients to talk between the microservices, for instance, which is very powerful and makes it very scalable as well. Next thing is the powerful framework and tooling that provides this great developer experience, but also give the right level of confidence to your team and make sure to prevent any bad pattern. The other thing is the Apollo router. So it's basically the gateway. In Apollo Federation version 2, it has been rewritten in Rust, which is much more performant than Node.js, as you might know already. So it's also very important because basically the router is the entry point for every single API call. So every milliseconds count for sure. Then and more, like the schema registry, for instance, but I won't cover it in this presentation. But if you're curious to learn more, feel free to come see me afterwards. For the migration plan, so we've built it in 3 milestones. So first, we wanted to switch to Apollo router. So basically, we won't make any change to our current schema, so the front end wouldn't even notice the change, which allow us to gain some experience with Apollo Federation for sure. But for now, it's mostly to get rid of the different issues we had with the previous solution, but we won't use actual Apollo Federation feature. Then the second step would be the domain split. So like I mentioned earlier, where does it make sense to make the split and which kind of subgraph we should end up with. And then afterwards would be to create those subgraphs. And we thought of basically keeping the old solution running in parallel with a brand new Apollo router that would talk to those new subgraphs. And we would basically slowly migrate the queries happening in the front end to slowly start talking to the new router with obviously the end goal of deprecating the old setup and fully work with Apple Federation. And where do we stand now? We're actually only at step 1, at least at the end of it. So we gained some experience with Apple Federation, and I think we ended up with a pretty nice setup using a monorepo. The goal is to basically have all the federated backend services within that monorepo. You see in the middle the contentful proxy. So we actually had to also create a proxy service because Apple Federation doesn't support hooking third-party APIs out of the box. But yeah, that was really just to support our current architecture. But for sure, the future architecture wouldn't have wouldn't need this contentful proxy. So here the graph is actually showing how we can start everything from one single command. So in this case, it's yarn start. Then it would start all the different subgraphs. So for now, we only have the contentful proxy. We'll build it because it's written in TypeScript, and then start the server. Once it's available, the Apple router kicks in, compose the super graph, which is basically the aggregated schema from all the different services. Then it will install the router if it wasn't already installed, which is basically downloading the Rust binary. And it will start the router. And so you would have at the port 4000 the Apple sandbox where you can test different queries, and also have a visual representation of the query plan that I mentioned earlier, which is really useful for debugging. So that was basically it on my end, and I hope it was interesting. And I'll leave the final word to Synda.
Yes, just thank you for your attention. And yeah, we are happy to listen to your questions and answer it as much as we can. Yeah, the stage is yours. Who wants to start? Yes.
Curious, is Ruby on Rails your legacy code, or is it like your modern backend?
You want me to answer it?
Great question. Actually, we call it legacy, but it's still our current right now. But we want to move away and start, exploring different services with different languages, and not stick only to Ruby on Rails.
What languages and platforms do you have in mind?
Ooh, we have a lot. We have Go. We have maybe Rust. Those, I think, the first two that comes in mind. But yeah,
It's still to be decided.
to be defined. Yes.
You mentioned the subscription.
Yeah.
A few of your slides. How does it actually behave when you're doing a schema stitching with the subscription? Like, does it have some sort of buffer that it remembers the last paper that was sent? Because, of course, not all the events are being delivered at the same time.
I'm not sure I understand the question. That's it. That's because you're probably mixing it with GraphQL subscriptions, which is not what we meant here. It's actually the microservice is called subscription that handles the subscription program add-on.
Hey, I'm quite new to GraphQL, so I hope the question will not be too boring. It's to you, Synda, about stitching.
Mm-hmm.
Since you can send queries to multiple microservices, with one query that is stitched together. How do you handle authorizations to these various services? Do you do it centrally, or is there a good way to do it?
Yeah, I can take that one. It was actually one of our issue. I mean, at the moment, like I said, we only have 3 services that we talk to, so it's not such a big deal. So we actually have a central point, which is the user authentication is happening in the legacy API, but we still have the subscription service that also needs to authenticate the user. So it actually has this, so we need to maintain the API client that will send the query to the legacy API with actually a REST endpoint. And so that was one of the main issues we saw, that it wasn't so scalable, and that's why we thought that, yeah, Federation was great regarding this, because then we can really have user authentication happening at the top level of the query, and then if the user is authenticated, then it continues the journey through the other subgraphs.
Do you know?
So you mentioned earlier that you did a dynamic schema with GraphQL, and I was wondering, is that something which came out of the box, or which issues you faced implementing that? Or what was difficulties maybe, or like?
Actually, it didn't come out of the box. Actually, it was really enabling by the use of this external API with Contentful, that the fact that we can auto-generate from a certain model UI, you can auto-generate the schema, which make it easier for our front-end developer to, don't have to call the back-end engineers to do some mapping with their fields, and then it's done automatically.
But it's not changing at runtime then?
Yeah, it could change. So it's changed when you change it, actually, on the UI. It changes directly on production. So this is why it was problematic for us if we do some changes, especially if you rename some of these fields without informing the others. It could make some errors. Yes?
That's it? Or? No!
Again?
I will do one more question. Again, I'm new to GraphQL. With the stitching, since you're calling different services, what is a good way to handle errors coming from the different errors coming from different services? Do you do it with a middleware, or do you do it in the stitching itself?
In the middleware. You mean the gateway?
I would say that's still something we should explore. At the moment, error handling is just done at the microservice level. But again, the way we use schema stitching at the moment, it's all top-level queries. So we don't do what I showed with Apollo Federation, that you can actually mix also the fields. So at the moment, we don't have so much problem with that. But yeah, for Apollo Federation, that's a good question. That's still something we should explore. And yeah.
Awesome. Okay, let's.
How many teams work on this project? What's the organizational structure behind it?
Could you repeat the question?
Yeah. You said something about how many teams is working on the project. So project, I guess you mean the website. It's
the whole thing.
Yeah, the whole thing.
Supergraph, all the components involved. How many different teams working?
So we have around 40 engineers, but each team, we have close to 10 teams now, I think. Or
Yes,
I mean, it's just growing so fast. I lost count. But and then so I'm only talking about engineers, but each team, at least the feature teams, also have product managers, UX, UI designers, data science. So it's it's a much bigger team. But we are, let's say, until now, having this smaller architecture with only 3 microservices was, so we ran into some issues, but it wasn't so bad until now. But since the company is growing so fast, we wanted to look for a solution that is more scalable and having like each team owning their own microservice, so own subgraph.
Okay, so one more.
Like, isn't it easily to run into like name collision, adding a lot of different services that you can compose query? What if we run into like a name collision? We have a lot of user type that actually mean completely different things in different services. What will we do in that case?
It is solved by the. So you use the Rover CLI with Apollo Federation, and basically, like I showed in the graph at the end, you run the super graph compose command, and this is basically taking the schema from all the services, put them together, but it's also taking care of type conflicts and naming conflicts. And in some cases, it's only warnings. So if basically you define, so in Apollo Federation version 1, you had to like explicitly extend the types using a directive, but in V2, you don't have to do it. So I mean, as you can see, as you saw with the user type, for instance, so if you define the same type in different services, they will merge the fields if they don't conflict with each other. But it's still going to be a warning in case it wasn't intended. And if you basically define a user type with an email being a string, and in another service you have the same user type and email field, which is an integer, then it will throw an error. I mean, I don't know why you would do that, but still. So you have the Rover CLI helping you with that.
Awesome. So grab a drink, and then we go for the next.
In 5 minutes? In talk?
Thank you.
Awesome. Yeah, just wait, just it's screwed up.
Oh,
Why am I mirrored? Like in infinity?
The setup.
Okay. Ah, because it captures the screen. Amazing.
You're a smart guy.
Yeah, hi everyone. I'm Michael Staib. I said that already. I'm a GraphQL TC, and I will be talking about GraphQL Fusion, a bit awkward. It's also about distributed GraphQL, but better. No, just joking. Okay, before we talk about distributed GraphQL in general, let's talk actually about GraphQL. So why should you even care about GraphQL, especially the ones that are new to GraphQL? So there is a Gartner study that came out recently, and they said by 2025, more than 50% of all enterprises worldwide will be using GraphQL in production. That's up from 10% in 2021. So GraphQL is really growing rapidly, and you can see that even when you look at the bigger companies that are now moving in. Like Cloudflare now dives into GraphQL to give you basic firewall capabilities on GraphQL. Microsoft is going into GraphQL. They are, by the way, using hot chocolate underneath, but okay. But they are going into GraphQL. IBM is going into GraphQL. So all the big players are moving into GraphQL. So you should be interested because it's the next big wave in technology that is coming in API technologies. That doesn't mean REST is going away or these other technologies, but GraphQL will take a much bigger role. So let's talk about GraphQL, why front-end engineers love GraphQL, and why I think GraphQL is really so cool. So this is one of our demo applications that we use in workshops that we do. It's a crypto coin marketplace. It was a cool example when we envisioned it 2 years ago. Now it's like everybody is sad when they see the old prices that we captured 2 years ago. But anyway, it's still a good example. So
Who is we?
So who is we? Yeah, Martin, my colleague there. Also, you see the rest of the organizer team all working on this stuff. So when we talk about these applications, then we often talk about components, right? And GraphQL has that baked into the language. So in GraphQL, we have a construct called a fragment. And a fragment is the data contract for our components. And that means we can now co-locate our data needs and the actual data usage in our UI components. And that makes GraphQL so rich and beloved by the front-end engineers. And all this makes everything compile safe. So if I compile my front-end, I know it works with my back-end. There's no like the issues that you have with OpenAPI, where we have a schema that says what the backend will do, and the backend actually doesn't do it. And that means as we compose our components, compose our fragments, we're actually composing GraphQL queries. So as I build, as the front-end engineer, put components together, they become suddenly a GraphQL query that I can execute against my backend. And that's the superpower of GraphQL, actually. And that works because GraphQL is a unified API, a monolith. And it gives the clients who use it the power to ask for what they need and only or exactly delivers what you asked for. As I said, GraphQL is a monolith. And that's actually a good thing. Think about this. Facebook, one of the biggest GraphQL setups in the world, is actually a monolith. They don't have a distributed setup. They have a single GraphQL API. And they're quite happy with it because it's very easy to debug. Think about a distributed setup. You have to proxy stuff around. It's always difficult to test things that happen in production because you have to have all these components on your box or reroute the traffic to some other place. And it's also easy to keep it up to date. And that's why Facebook actually stick with this monolith. They nowadays have a couple of microservices, like the search service, for instance, but basically they still have a monolith of around 10,000 types, 300,000 fields. And they have one of the heaviest pressure against the system that you can think of. I think most of us never go into that realm of traffic. But a monolith can also slow us down. Like, it's difficult to update. Like, it's easy to update because we can update it all at once, but it's also difficult to update. If I, for instance, want to use this new package of something in just a part of our monolith, then I have a problem because I might have to update this package in all of these components of my monolith, right? So it also hinders you of more or faster iteration speed sometimes. And it's also limiting us in flexibility. So a monolith can also hinder us. What most people say, and that's not true often, is that it's difficult to scale. So it's more difficult to scale, I agree. And that's actually where people then throw the microservice term at the wall and say, let's do microservices. They are much easier and they scale much better, right? Because they give us all this flexibility. Every team can work in a different technology. And that's a good thing, or? And there's also, like, teams can work independently. Every team can work on a part of something, and it will all work out together. And on top of this is much more resilient. At least that are the promises. But actually, it increases a lot of complexity. You have to think about network latency suddenly, or data consistency, because you want to have overlapping data to actually make microservices worth it. And there are a ton of other problems. But the most important problem for me is it's difficult to consume. That's actually what we had with GraphQL, the nice thing. There's one API to consume everything from. And what you should really think about before heading into distributed GraphQL, and I'm not saying you should never go there, but always reflect why you go there and reflect why you want to build buckets. It's a concern of separation. Because often what we see when we go to customers is that they want to separate business verticals. Basically, they want to separate topics. And it goes so far, and we did that actually at Swiss Life, where we had these small components. I don't know if Philip remembers. We had these small components, and each of these components had its own repository. At some point, we had more repositories than employees. Think about that. Nowadays, we are deleting all these old repositories, but it's sometimes that we just want to have these separations. So we built a distributed service and all these microservices just because we could use a folder. So think about, is it the right thing to distribute my GraphQL setup? Is it the right thing to do? A good concern for separation is actually thinking about organizational boundaries. What that means is you have a lot of teams. That's actually why I think Pascal did this trick question about how many teams do you get in on, because that's if you have a lot of teams, a lot of developers, that's the right point to think about distributed GraphQL. Not to just build these buckets. Then you can also build a modular monolith, and you will have a lot less sleepless nights. Another thing that might be a good thing to do a distributed setup is maybe that you have scaling constraints. Like, as I said, Facebook scales this monolith quite well. But there can be benefits to use a distributed GraphQL setup to scale your services in a better and easier way. One thing that I don't find a good concern is that you use, like, every team uses its own technology. Think about a big company like Swiss Life. How many teams do we have at Swiss Life? 20, 30, 40? Yeah, a lot. Think about each of these teams uses their own stack. Just chooses anything that they just happen to love at that point in time. You would end up with 50 different technology setups, and you couldn't reuse anything. Like that an organization uses three different stacks is maybe a good thing to do. and then you have still benefits. But if now every team in your company chooses their own rules, chooses their own naming guidelines, then you will end up in a hot mess. Okay, let's talk about scale before we talk about really distributed GraphQL. So when we talk about scale, we really have three axes here. It's data, throughput, and developers. As I said, developers is the main thing you should think about when you want to go into distributed GraphQL. So when we're talking about scaling data, then we typically talk about regionalized data. So data that sits in different buckets, and we want to have this data closer to our users, to our consumers. We call that partitioning or also sharding. And sharding is the method to split our data or to distribute our data across multiple regions, files, folders, machines, whatever, right? Distributing your data. And then in a distributed system, when we ask for something, we would actually ask for this something in a different bucket. Another concern here could also be that you want to isolate data because of regulation, right? Could also be a concern for this kind of partitioning. The other concern here is throughput, as I said, scaling throughput. And when we talk about this, it's actually about a lot of requests hitting your system. And you want to scale your system so that each of your instances takes part of the request. And in this, the unified API might not be this good thing, because suddenly we're having to scale always the whole monolith, right? So the original setup that Facebook actually did is kind of this. They had this thin layer of GraphQL on top of a business layer. So they first built the business layer, and that was everything Facebook does. And they had the REST API on top of it, or their Graph API. Actually, if you go to graph.facebook.com, that's their REST API. They just called it the Graph API. And on top of that, they built then, at some point, GraphQL, because they wanted to give the ability to the user to pick and choose what they need in which components, so you don't have to build a BFF for each of your consumers. And that's actually also why why Netflix went into GraphQL. Because at some point, they had BFFs for, I think, 10 or 12 clients. And think about the maintenance headache you have there. So when GraphQL actually became public, what people would do is not put it on your business layer, because many people, most people in the wild didn't have this monolithic, nice, done architecture. They actually had a couple of crappy REST services lying around. So what to do? Put some GraphQL over it, and it's nice. And it really is. It really is. We have this thin layer of GraphQL over our existing infrastructure. And what we could do then is actually give meaning to our things that we had there. Maybe we had reviews and stuff like this. Suddenly we created review objects. And GraphQL has a full type system with interfaces, unions, and all these constructs, more than you have in most languages. And we started connecting these with connections, and we gave meanings to these connections. And suddenly you had this explorable graph, and front-end developers just started to shake because they couldn't believe how awesome GraphQL is. And the good thing, if you think about that, is that if you have now these REST services behind that and do requests against your GraphQL server, then actually we are scaling quite well behind that, because if we just ask for products, then we are maybe just using the product service. If a different client asks for a lot more data, then we are asking for more services. So basically, that's how we came up with stitching. So now throughput scaling is not really a reason, as I said, to go into distributed GraphQL. You could also just put your GraphQL layer over your infrastructure, and it would scale quite well. But scaling developers is a lot more difficult, because if we did this setup, then every time somebody in some team who changed something in their microservices also had to change something in the GraphQL layer because we always had to deploy them together. Otherwise, we end up with broken APIs. And that is the same problem that we actually have with schema stitching, right? So that's where we really go into distributed GraphQL. And in distributed GraphQL, what we basically did is swap out these downstream services, these REST services, with GraphQL. And we would label them subgraphs. And we have a gateway, and this gateway composes an overall gateway from these subgraphs. And behind that, if you want to push it to the top, you can still put your microservices, right? That's actually the architecture of Netflix, the one-to-one architecture of Netflix. They have these subgraphs, and each subgraph uses a couple of microservices to get the data, and the microservices can talk to each other in Thrift. To make that a good setup, as I said, think about the concerns of separation. What you want to do is cut them that one team owns not only the subgraph, but also the microservices behind that. Because this way, they are owning a portion of the graph. And they really can push that and update the overall graph independently of the other teams. So let's talk about GraphQL Fusion, because that's a new approach to distributed GraphQL. So why did we create it? So in the beginning, there was stitching, and everybody actually did a different version of stitching. There was hot chocolate stitching, there was Apollo stitching, there's Nadel, which is actually it's called Nadel. It's the Java version of stitching, which GraphQL Java introduced it. So everybody did a bit of their own stuff. Then Apollo came up with something they called Federation, which is a new approach that pushes the configuration to the subgraphs. But it's actually bloated and difficult to set up. You have to do a lot of federation stuff. The second thing is why the guild and actually we, ChilliCream, started building GraphQL Fusion is because Apollo Federation 2 is patented. So it's not an open standard. And that's why a lot of people are not implementing the Federation 2 spec. And also, like there is a legal not quite, is a gray area. If you can use it, the license term says you are not allowed to run it as a service company. So that's why a lot of GraphQL companies actually started to looking something new. That's where Fusion comes in. So with Fusion, we took the approach to actually go to zero configuration. So one of the main aspects we wanted to introduce is that you don't have to, I don't want to use that term, what is the term? We don't want you to mutilate your subgraphs with stuff that is federation specific. So with federation, you end up with subgraphs that are not really GraphQL anymore. Basically, all queries run now through this entities field, and it's actually what you don't want to do with GraphQL. And that's where we rethought this approach. Like, take all the benefits that Apollo Federation has, but remove all the downsides. So we still want a decentralized configuration, ideally a zero configuration approach. And we want to have a composition on build. And that's really important because you don't want to have the surprises that you have with schema stitching, right? We want to have strong query plans. But we also want to have subgraphs that can be valid in multiple fusion graphs, and that also can transform these subgraphs. So maybe one of your teams has different naming patterns. So we want to just define rules how to align that into your overall graph. So, but let's have a look at some code. I talked a lot about these concepts behind it, but because it's important that you reflect. I don't want to sell distributed GraphQL just because it's cool. You should always reflect why you should use it. If your company just has a team of 7 or a team of 5, don't go there. Build your monolith. Okay, so this is a simple setup. I have here an Apollo GraphQL server. It's basically a very simple GraphQL server where we have a user. We have a couple of methods here. to fetch a user by ID, to fetch multiple users by ID. We also have a user by username and things like that. So a simple account service. And there is actually, if I look in the TypeScript file here, not a lot to it. It's also no proper database here. I just put it in memory. So a typical demo service. But it's TypeScript, and I had to ask for a lot of help to write it. Martin actually said how I have to do it in TypeScript. And I have here a review service. This runs in C#. That's basically the hot chocolate setup. It's even less code, but okay. No pun intended. Okay, so these services run here. You can see I had a schema here exported. That's all I have. Basically, the schema file is sitting there, and I have nothing done to it. I can also go to these GraphQL servers. So we can go maybe to this guy here. And yeah, we have here this ugly Apollo console. That's actually, now it's just fun bashing them. So, okay. Sure. What do I want an update? Sure. Huh? See, works always. Okay, so this banana cake pop, we have a lot of strange names for our products. This is, I would say, personally, I'm biased here, but it's the best GraphQL IDE you can get. But it doesn't work. No, it's kidding. No, it's just not HTTPS. So, okay, so it works. So we have here a schema explorer. I can just go here in the column view and explore a bit my schema. And as I said, it's a basic schema that we already saw here. I could write a couple of queries against that, like users and stuff like that, right? And it should give me stuff, right? Add a Lovelace and Alan Turning. I can also go to the second subgraph. Let's quickly grab it. This guy here. Not this one. Let's paste it in. And this one is, as the spec actually says, on the GraphQL route. No pun intended. And we can also go here into the schema reference. And then we have here also other things. What you can see here is that we have here authors. And the authors is actually the user, right? In the other graph. And we also have other things, like we have reviews here. We have a product ID here. We have a review, and the review has an author, and things like that. So what I want to do is bring these two graphs together to fold them into each other, and then we're going to query them. So how do we do that? So the first thing we learned already is we have a thing that is called a gateway. So to create a gateway, I'm using here a template. That's the hot chocolate Fusion template, and it's called basically the GraphQL gateway template. So I'm doing just a .NET new GraphQL gateway. Creating that. And all there is to this gateway is actually this piece of code. That's everything. You can configure other stuff into it if you want to have different kinds of propagation of headers or whatever. But that would be just layering on top. But this is it. And we could just start this guy here. So we're going to do a .NET run. And then I'm just running the gateway. So at the moment, the gateway actually doesn't have a configuration. So it's basically dumb. It has nothing to it. So what we need to do is actually compose here our subgraphs into the gateway. And as I said, everything is meant to be done on build time. So you get build time errors. So what I'm doing here is using the Fusion command line. So we are saying .NET Fusion. And then we say compose. We want to compose our gateway. And actually, we want to use here the accounts subgraph and to compose it into it. So I've done that. And the gateway is running, by the way, so it hot reloads automatically and would have immediately the other GraphQL server in there. So let me get rid actually of this guy here. We look at the schema, and you can see it's a one-to-one stitch, if you will, so a one-to-one composition. So at the moment, we basically have the same than we have in this other subgraph. So I can query that, and it works. Awesome. So now we go and compose the second subgraph into it. So I'm just saying reviews. Composing that, and there's 0 off time because we slowly phase out the old schema as we phase in the new schema. All the requests that are happening in between are going against the old version as new requests are distributed the new schema. And you can see now we have actually a lot of these other types here. And the interesting thing is I can go to user, and user has reviews, although in the other server this was author. But we bring them together because we know your naming roots. And so we can overlap these data. So let me query that. So we can now go here in users. We can drag into the reviews here, the reviews that this user wrote. And from the reviews, we maybe want the body. So we query that, and we get that. This is 2 services actually working with each other. Or maybe not. Let's have a look at that, because we can opt into the GraphQL query plan here. Say we want to activate the query plan, we query that, then we collapse actually the data section, and we get here the query plan. And actually what our gateway found out, what the composition found out, is that we have overlapping data that lives in both places. And that means we can actually rewrite everything to get it from the first graph, although the first graph didn't have users. It just had authors, but it also had an authors list, and all this data is actually living on both graphs. The moment I ask here for things like the birth date, which only lives in the account service, I get a different composition of a query plan, where I now have 2 hops. And the interesting thing is, we are not using any hidden fields like the entities field. We are just using your clean GraphQL graph. And you can see here, we are aliasing authors to users to map it to the overall graph. And then we are writing a normal query. And then we are collecting here all the user IDs and pushing all the users' IDs in the second graph into a field that can fetch many users by many IDs. So we recognize what batching fields is, compose them into, and distribute your IDs here. This gives you a much better performance characteristic if you think about writing these resolvers, because you can write very explicit resolvers and don't have to write these reference resolvers anymore. Okay. Let's actually kill that, because we have a couple more cool things, like subscriptions. Okay, but let's resum that, what we did. So Fusion is a more natural approach to distributed GraphQL, because we don't use any hidden things. We use your normal GraphQL server. The Fusion graph composition works that we take 2 types, we overlap them, we merge them, and we know what is overlapping. Like name, for instance, lives in 2 things. Or birthday just lives in 1 thing. Or review lives in the other thing. And the best thing is you can have error policies that if one of the subgraphs is down, where we have overlapping data, we can actually track that and then reroute the traffic to a subgraph that is still working. And your overall graph will not be affected by these downs from some subgraphs. So when we take these subgraphs, we merge them to a single Fusion graph. And that is done basically at 2 steps at build time. Basically, we build your subgraph, then we pack the subgraph configuration, and in the second step, we download the current Fusion graph config, compose your new graph into that. Let's have a look. A Fusion graph has all the information about all the graphs that ever were composed into it. So we take that, and then we compose the new version, the new subgraph, into this overall Fusion graph. And when this is done, we know there can nothing go wrong anymore. So we can just deploy both things. So first we deploy the subgraph and then the new schema. OK, let's skip over that. Let me show you one more cool thing. So I have one more demo, and then I'm over time. We're not good with timing this meetup, so I'm very sorry. OK, let's actually do a quick thing, because what I want to show you is actually another demo that is cool. So does anybody did ever a subscription with Apollo Federation? No? It doesn't work. OK. OK, let me show you how we do that with Fusion. So I have here demo 2. And I already have a gateway here. So let's quickly start it. The downside to this kind of demos is that you have to start a lot of subgraphs, the more complex your setup goes. So give me a second. Subgraph, and here's reviews. And then we go .NET run subgraphs. What do we have here? Accounts, maybe. And last one. And that is product. OK, they should be all on. And we go here to our gateway. So this schema is a bit more, it's the same demo, just think of it as a couple of iterations ahead. So we have now a lot more types here. Like we have a query, we have a mutation, we have also not only the reviews and the users, but we also have a product, things like that. And the use case I want to show you is how we can now introduce a subscription here, where when you write a review, we get basically a subscription trigger that sends to the user in real time the review that was created. So basically, you can hook onto that, and you get all the reviews that are created. So let's dive into that. So this thing should work. Let's make sure what I'm showing you here actually works. Does that work? No? Yeah, it's a bit different example, and I actually have here the queries already done for that. Fusion demo is, I think, let's see quickly, it's demo 2. Yeah. Not this one, this one. OK. So I can write here basically reviews. You can see this is a review. Here's my execution plan. Because I have the header on, basically I created a new review here. I get back the ID. Simple thing to do, right? So what I want to do is now introduce actually a subscription. So to do that, I'm going here to my subgraph, to the product subgraph. And I already prepared here something, not the product subgraph. I lied. It's a review subgraph, because it's about reviews, right? We have here our mutation. And I want to add here actually a subscription to it. I prepared that actually, so let's just introduce that. So I have here basic subscription type, and we now have here a subscription that listens to a mutation create review event and will then yield the review that was created, basic subscription stuff, right? So how do I get that into my subgraph? So let's actually find out which is the review. This products, reviews. OK, so I'm just closing here my review subgraph. What I want to do is export the schema here, because the only thing that we need is an exported schema at build time. And then we can do a Fusion subgraph, and then we pack this subgraph. That's what I showed in my slides. So we pack the subgraph configuration, and then we do a Fusion compose. We compose a new gateway here with this review subgraph. And then we just run our review subgraph again. So I just added the subscription, and then we are rerunning this thing. OK, then we can go back here to our, this guy here. this still works, right? We tried out, so it works. And now I'm going here to the second thing. That is actually my subscription, because now we actually have a subscription. If I refresh here, you can see subscription is there. I just composed it, subscription is there. And that means we can just hook up to this subscription, execute it, and this is typical for subscription, nothing happens. Because we are waiting for something to happen, right? So I can go here and now just invoke that, and then data is here, real time. And just to prove, this is 5 stars, let's make it 4 stars. And go back here, run it, and it works. And it actually works, like my subgraph actually only supports GraphQL WS, but what I'm using here is GraphQL SSE. So the gateway could deliver the subscription in a complete different protocol. So we subscribe to the subgraph in the supported protocol, then deliver the subscription maybe in a different protocol, the protocol that your user wants to have. Okay.
Shows the console. You can see it there.
Ah, yeah, Rafi actually built a console here for transport. And that's actually cool. Because we can, yeah, that's the messages actually. You can see, oh, that's because the demo case is now much nicer. I can go here, and you can now see real time, right? How the messages come in. Yeah, I didn't try that out. Okay, the subscription we done. Also, that's also like if you go to the Apollo Federation repository, there's tons of issues open for the relay pattern. So if you're using relay, it's very difficult with Apollo Federation. Like the most prominent, the node pattern is open for 2 years, no implementation on it. With Fusion, we rethought this thing, and it actually, like at the moment, there's no node pattern here implemented. This is node pattern. If you do relay, you know what I'm talking about. So in order to have that pattern implemented, we just go here, then say .NET Fusion Compose, then say enable node pattern, and go back to our gateway, refresh that, node pattern works. That's how easy all the GraphQL best practices work over Fusion, and that is not possible with Federation yet. Okay. I took too much time because we have another talk. Again, GraphQL Conf. If you want to know more about us, you can connect to us. Like all of this is MIT. The Fusion spec is MIT. That's one of the important things that the guild and we wanted to make sure so everybody can implement it. And it's an open spec. So spec is MIT, implementation is MIT, and also the guild will do an alternative implementation in their stuff, TypeScript. Okay, that's it. Questions? Go ahead.
Hello, thanks for the presentation, super interesting. I was wondering in the first demo you showed where you suddenly the author and the user were the same thing. How is this configuration done? Like, and what? Yeah,
basically, so what you can do in Fusion is register some naming rules. So team A says, okay, semantically, these are our names. And then they also say, okay, when you go in this subgraph, it's basically translated. And that is done with the directive. So you can have a rename directive, add rename, and then you can say, basically, rename me these patterns into this and that.
So in case in the two different APIs there would be user, but it's actually not the same thing for whatever reason, you could make sure it would still work then.
Yeah, because that's one, like when you read the Netflix blog, that's actually the problem they had. Different teams had suddenly different naming patterns, and they couldn't get that into the federated graph anymore. So we baked that in. Like Fusion fuses really the concepts that you had in stitching with the concepts that you had in this federated approach, put it all together and give you all the flexibility of both. while still having the peak performance. And like there's always this argument made that Rust is so fast, but Fusion in .NET is actually outperforming the Rust implementation. And I think WunderGraph, I don't know what they are using. I think TypeScript is also faster than the Rust router of Apollo.
But sorry, just to follow the question, because you say that there are no configuration in the GraphQL schema to keep it pure.
Yeah.
So where is this alias configuration?
I show you roughly.
Because there is a piece missing. Like if
yes,
you start,
I
if you
skipped
start
over
a
it
new
because of
from
timing.
scratch. Okay,
Yeah,
just to understand.
Let's. So this actually doesn't have anything. Do we have here? No, nothing. No configuration here. There's, for instance, a configuration. So what we can do, but you see, it's almost nothing. So what you can do is give us semantical hints. Like this is the is directive. It's one of the directives we have. You can basically say this ID is semantically equivalent to the field ID on product. And then we don't need to know that it's a key or whatever. We know the semantics of your schema, and then we understand it.
Okay.
You need no directive if you implement the nodes pattern, because then we have semantical knowledge about what nodes are in your graph. Like if you use GraphQL best practices, no configuration. Okay. But you can do this. What you can also do is have general rules, and these general rules you can also have for the schema. So you can set up a dictionary somewhere where you can actually say, okay, there is a rename thing. So we have a rename, and then we can define, there's a GraphQL schema coordinate spec, which is at the moment in draft stage. And we can basically use schema coordinates to rename parts of your schema and apply these rules then in the overall graph. So you can keep your semantics, but we will find out and replace these patterns. So this is also what you can use, kind of.
Can you scope this rename related to
Yes.
some subgraph?
Yes. So this is at the moment scoped to this subgraph because I have it co-located.
Okay, thanks.
But you can also co-locate it with the gateway, then it's for all. So we have two so there's a composition pipeline. You can even hook into that. You can even hook, that's also a cool thing, you can even hook into the query plans, right? And say, okay, I have a super optimization that is only for our company, so I'm implementing like a query plan node and hook it in, and we will recognize in the composition pipeline, and then, yeah, it's when you go into the more edge cases.
So you had this shown where you have transformed the schema and faded one out and then faded another one in.
Yeah.
I actually watched your video where you did this on YouTube, like where you added some fields dynamically to it. And I was wondering, like, where is that implemented, and is that something which is covered by the full spec, and like, will it also be available in other language, or is that something that is specific implemented in the your engine kind of?
That's specifically to Hot Chocolate. Hot Chocolate can do these hot swaps.
Okay, that's covered by the full specification. So
no, the specification just talks about GraphQL as a concept, like how GraphQL works. And the GraphQL schema is actually immutable. It's also immutable in Hot Chocolate. What we do is a schema swap. So we create a new schema.
Yeah.
And then when this is fully created, we start phasing out the old one and phasing out the new one and basically redirect your traffic.
That's all hot chocolate stuff.
Yeah, that's all Hot Chocolate stuff. There are maybe others, like I could imagine that Hasura has a similar technique because they also do these live schemas on Postgres and things like that, so you would need similar things there.
Okay, thank you.
Could you explain how we do the phase out in detail?
Michael, can you repeat the question?
Yeah, like you're just saying, we're phasing out this thing.
So
what does it mean?
So on the transport layer, in GraphQL, we basically have an active schema. We did that in the way that we have a proxy around our schema. And when we do request against this proxy, in this proxy sits actually an active schema. So while the transport is executing against this, we can at some point say, okay, these requests are now executing within this active schema. At some point we switch it out and new requests now go to this new schema. That's basically what we do.
So it's an if state?
No, it's more. It's not that easy, no.
Yeah, I was wondering, does it support persisted queries on the subgraph?
Yes.
Okay. Because
it's even so. So this is cool. Like in Banana Cake Pop 7, you will see a lot more of that. So you can manage these persisted queries. You can. So what we think about that is not yet implemented, but that is coming. So we will actually take your uploaded queries into our schema registry, precompile these query plans already in the schema registry, and then tell you already which are too slow before you ever executed them. Because we know how many hops they have, so basically we determine how many hops they will do to your subgraph, and we'll give you tips on how you can make that faster by telling you, actually, if you put some overlapping data in this subgraph, we can redirect the data there as well, and we would optimize these 500 queries of you.
My next question was mostly about the load balancing between all of the subgraphs, because you mentioned the error.
Yeah.
Like you skipped
so the
over
subgraphs, that is in all the cases, they scale independently of the Fusion gateway. So that's the beauty of it. You have a very small Fusion gateway that should have minimal time of throughput, right? It should take minimal of the time. Like we have precompiled query plans. So it's super fast. And then you can scale down there your subgraphs. And that's the thing you scale. The Fusion graph, I would say, you will not need so many. You can scale them just. But
you mentioned that like if there's an error in one of the subgraphs, you're gonna kind of escape and
that's the error rerouting you're referring to.
Exactly.
Yeah.
So I was wondering, I mean, this kind of.
So at some point, everything breaks, right? When enough subgraphs are gone. But that is a thing we are still fine-tuning on. It's error rerouting. So that's also why I talked about partitioning and stuff. Like if something goes wrong and you have overlapping data, we always have alternative query plans. And then we take a query plan that has the least amounts of errors. Like basically, if we see subgraph 1 is down, and we can maybe get 5 more fields for this query plan from some other subgraphs, we will take that and you have more data in your things. The GraphQL error rules apply on top of that. But yeah, we will do error rerouting there.
So somehow it does some sort of load balancing.
Yeah.
Somehow.
Yeah, we said that there is tons of concepts behind that.
Last question?
Yeah, because we have one more talk.
Who?
And the audience?
Last question. Who wants it? Last chance.
Otherwise, Michael will talk forever.
Yes. Okay. I'm unplugging.
So then I have another.
Thanks.
Should I take the question? I can ask him later.
I don't know. You want to take another question, Michael?
Let's because we have one more
Later.
talk from Smartif.
I'm sorry.
No worries.
Yeah, and that's also awesome about full text search in GraphQL on relational data. So maybe everybody grabs a drink while Thilo gets ready, and
Who of you attended the last one? Yeah, well, then you already know us. I'm working at SmartIF. The last meetup was hosted by us. So, yeah, we already do some GraphQL on different projects, for example, Zweiwelf and Wikipedia. We also do teaching at the HSR, for example. And yeah, but now let's dive into today's topic. I'm going to show you how we build up the new API for Migusto. Let's try to show you the Migusto page here. Yep, perfect. Who of you already used Migusto? Anyone? Yeah, small of them, okay. So it's the search, no, it's the cooking community from Migros. And there you have tons of recipes at its core. So here on the page, we can search for lasagne, for example, to get the results matching recipes. And we also can search for, let's say, some ingredients, works as well. And it even works if you mistype something. So if you say salot, whatever, still gets the recipe, or for lasagne as well if you mistype that. Let's say lasagne with M. So you still get all the recipes, even if the search query has some correction mistakes in it. So we were tasked to implement the new recipe API for Migros. They already had some kind of recipe API for their old website, which was called Saisonköche back then. Maybe some of you remember that. It was mainly the printed magazine, but also the web page. And with the new API, we wanted to make the result and search experience as much as possible better. So we managed to improve the overall search results by 20%, and the API in the end was around up to 3 times faster than the old one. And I'm going to show you what we did to get that to that point of improvement in performance. And all comes down to the 2 parts. We chose to set up a GraphQL API, and in the backend, Elasticsearch as a full text search engine. So let's look at the requirements shortly. We already seen the search result list there. We have several recipes, but for every recipe, we only need a short part of it. So for example, the image, the title, the ratings, and the duration of preparation. But on the other hand, we have the detail page with much more details on it. So we need most of the data for one single recipe. But that's not all. When we started implementing the API, we didn't know all of the consumers of the API. So it was difficult to know how our consumers will consume the API in the end. So that's one big advantage of GraphQL, where the consumer can explicitly specify what data fields they want to consume for their special view. So that's why we choose GraphQL, and because it has no over and under fetching, and that led to much bigger performance, only this small change as well. Now let's also look into the data structure, because that's one big part as well. If we have a recipe split up across different tables in a relational database, we have the base information of the recipe in the recipe table, then every recipe has one or more steps for the preparation, and we have multiple ingredients per recipe. And their ingredients, they have multiple products. So every ingredient has one or more Migros product, which you want to link to them, of course. But they are handled by a different API as well. So that's quite a challenge, even if you're using a relational database. The database itself has to make the joins over the tables for every single request a client will make. So if we have, for example, a consumer which would want to build a shopping list for the whole week with several recipes, for example, 10 recipes, and for every recipe, you want to have all the ingredients as well. You have one GraphQL query, that's really cool, you have one endpoint, but on the resolver level, if you, for example, have a separate resolver for the ingredients of the recipes, so the GraphQL will then make per recipe one additional call to the database to retrieve the information of the ingredients. So that's going to blow up the whole stuff quite fast. So in the end, you could end up with up to 51 database queries or subqueries on joins if you manage to optimize that a bit. So what we did here is we looked into how can we improve the response times here, and how can we even add full text search. So you want to be able to full text search on the ingredient names as well. So what we did here for performance optimization is multiple steps, but the first and important one is we had a look at our data, and we looked at it, which data of this is more or less static. Because on import we have time, and when filling up the data for the API, we have enough time to prepare all of that. So we choose to denormalize all static data into one single JSON object or data object document per recipe. So we merged the ingredients, names for example, into the single recipe data. You can't do that, of course, for dynamic data, for example, for discounts or product prices. But for all other, one more slide. So everything together will look more or less like that, JSON object, which we then can feed into our database for querying. And for all other requests or data which is not that static, we added some caching layer. So it's quite simple to add that to your GraphQL API on the resolver level as well. We just used the Redis cache to add that layer. And one thing we seen a lot, or we had to look for as well, is with GraphQL you go really fast into really deep queries. So we had to limit the consumers shouldn't be able to get into too deep into the database graph. So it shouldn't be possible, for example, to retrieve the ingredients of the recipes because that would blow up the API as well, of course. So that's really important to look at. You want to get a depth limit of your GraphQL query. Yeah, now full text search, that's all about data preparation, but now gets to full text search. Requirements, of course, we want to have some full text search on it. We might want to have some spelling suggestions or corrections. We need multi-language support, and in the end, we also want to have filters and aggregations so that the user can narrow down his subset of the result list. And there are multiple search engines which could come into place. And most of them all depend on Apache Lucene. So we chose Elasticsearch because we already used it in some different projects as well. And it's quite easy to set up and good to learn. But all the concepts which I'll show afterwards, I guess they're more or less the same for all these search engines. So if we look at the Migusto page again, you see we have the category filters here. That's one main part as well, which a search engine should deliver. We don't want the user to be possible to click on a category which would not deliver any results. So that should be possible as well, and that's one of the things Elasticsearch or the search engine can deliver as well. So now let's get to a deep dive. I'll go with you, show you shortly the details, how easy those concepts are possible to set up with Elasticsearch, but all the other stuff of setting up a search engine yourself, you can read that up in the documentation. That's quite nice. So the basics I have to show you, Elasticsearch itself, it just uses a REST API. You can also use it with streaming and stuff like that as well. But the basic part, you can get your recipe or data document, a JSON object, by issuing a put request on the GraphQL, on the Elasticsearch endpoint, and then it's indexed on the search engine. So we do this for all of our recipes. Of course, not one by one, but in bulk requests. But then, as soon as it's in Elasticsearch, all those fields you see here, we can do full text search on it, we can do category filtering on it, and it's all in one platform then. The query, the GraphQL query, which looks something like that. I can show you that on screen maybe if it loads. Yeah. So that's exactly the query which is used or was used. I don't know how much they modified it in the meantime. It was used on the Migusto web page when searching for something. So in the in the top, can make it a bit bigger maybe, or not. No, sorry, hope you can read it. So in the top we have the search term, where the user entered the Linsen, for example. Then we have the taxonomies. These are the filters which a user has. So here those two IDs are filters for, I guess, vegan and main course. And then we want to boost it by summer so that the currently seasoned recipes are ranked a bit higher in the search result list. And then as a result, we want all the aggregations. The aggregations, that's what it's called in Elasticsearch, the categories, which we want to show on the page for the user, which can select them for main course and stuff like that. So we say we want the aggregations on the taxonomy categories, together with the count, how many results it would return if the user would click on that category. And for the recipes itself, we just want the title, maybe the ID or something like that. We could add that as well, if I manage to click on it, yes. And now if I execute it, cool, I can't click anymore.
Yeah, maybe some banana cake would have.
Yeah, perfect. Oh, no, it's going, perfect. Yeah. So it returns quite fast, all the aggregations here. So we see most of the, it's learning on my local machine, so the count is quite low with 3. So, but most of the recipes I've got local are main courses, and then we have a lot of more taxonomies, categories as well. And in the end, you have the title, which is returned because I put out the ID. Yep, that's the API. How is it running? And now I'll show you step for step which all of these queries are mapped to the Elasticsearch query behind. So it's quite easy. If we have a GraphQL query, full text search for Linsen, lentils, which would return the ID and the title of the resulting documents, we just can issue a GET request on Elasticsearch by specifying a query string query where we put in the user's term request as a query and say Elasticsearch, it should look inside the fields title, description, and ingredients name. And then we want the ID and title to be returned. Same goes for filters. So the filters, we just specify the filters in the query, GraphQL query, which is then mapped to the GraphQL query below. It's more or less the same syntax. And the thing called in Elasticsearch, it's a bool filter terms query on the taxonomies.id document of the JSON object. For the returning fields, it's the same. Recipes, that's one cool thing of Elasticsearch as well. So we can do aggregations. Can be very simply done by just using the X aggregations query of Elasticsearch. You only have to specify the fields, which should be used for building up the possible categories for the search categories. And then Elasticsearch does all the thing behind itself and returns the stuff for you. And good thing here is we can build everything together. So we have one query at the end with the full text search at the top, then the filters here beneath, and at the bottom, the aggregations of the taxonomies which we want to be returned. So yeah, I hope I didn't have lost you on the way. Shouldn't be that hard to build that stuff up. But yeah, the main part which I want you to take away is the most part of performance improvement was one GraphQL query to one database or Elasticsearch query in our case. So yeah, to sum up, benefits of Elasticsearch or search engine generally, it's document-oriented, it's scalable and distributed as well, like a normal database, and it's very fast in data retrieval and full-text search, and it supports filters and aggregations at the same time. So you have one query, one result, perfect for your search page. yeah, to conclude, what we had to do to get to these performance goals, we had to denormalize the static data structures. And where this was not possible, we used caching for time-consuming requests, for example, for third-party APIs. We control for recursion on the GraphQL query level, that they can get too deep into a query. And in the end, Elasticsearch as a full-text search engine, together with GraphQL for the efficient data fetching, it's like a dream team for those use cases. So yeah, that's it. Thanks a lot. If there are any questions.
Rafi, check if there are questions. Ask. Questions?
Thank you. I was wondering how big the database is, or how many recipes you're searching through, and if you also had to implement paging for the GraphQL API.
For paging?
Paging.
Yep, and the database, it's around, I guess, 5,000-6,000 recipes. So it's not that big, but we also used Elasticsearch for bigger projects where you're much more inside it. So paging isn't the problem there too much, but of course, if you go to the last page, it's, yeah.
So you didn't build in paging in the GraphQL API in this case?
In the GraphQL API?
Yeah.
Oh, yeah, we have it implemented as well. Let me see. Can I show it again? Okay, I need to find it, sorry. I don't see anything. No. So yeah, with paging we have the same implemented, just with limit and offset.
Can you make it bigger?
Bigger?
Yeah, please.
Yeah, try it. Can you see it?
Better.
And something like that.
Any other question?
I have one, if you just send here. That's perfect.
If you insist.
I have a question about security.
Yep, nice one.
How do you validate the performance impact of a query that comes in?
I'm sorry?
How do you validate the performance impact of a query that comes in? Or do you have a limit in what's possible? Or do you somehow validate the input? Or you just let it go?
Of the GraphQL query, you mean?
Yes, I mean, if I look at it, it's like, this is basically the Elasticsearch query, right? That's exposed.
Mm-hmm.
So without knowing this, I might find out that there is Elastic use behind it because of boost and search and term and stuff. So maybe this is a vector I could use, or is this just?
No, it's actually a mapping in between. So you can't use all the Elasticsearch APIs. So it's not exposed one-to-one.
Yeah.
So that's a separate API, and we only let through the exact schema which we define.
Okay.
So it's only the top level. That's also why we control for depth. So you can only request the top level. So don't get any deeper.
Okay. Cool. Thanks.
Any other question? All right, you're making this difficult.
Voilà. I'm curious. I mean, full test search is amazing, but at the same time, you never know what the user is going to type. So, for example, if the user is going to type a list of ingredients, do you have thought like a way to prioritize to search for ingredient instead of the title of the recipe or vice versa?
Yep, good point, good question. That's what I showed you. It's just the really basic stuff of searching. So it's not the actual query which we are making to Elasticsearch, but there's much more behind it. So we have some weighting on the different fields. For example, if you have a full text match in the title, you want it to be prioritized up in the search list. So we have a weighting on different levels, and also it's not a must match for all the queries the user enters, but it's a point of balancing out, right? So we want to find as much as possible match or a good as possible match for the user's query.
It seems too simple to do.
Yeah, it's true that, of course, but yeah. There's always more to do. So the optimizing thing is the hardest part. Yeah.
Nice.
One last question. Then only beer.
What did you use before Elasticsearch in this case?
I don't know. That's not our API. Wasn't our. But we used Elasticsearch since the beginning at Smartif when we had to use full text search. So yeah, it was always our first choice.
I was asking because 5,000 entities in a relation database should be something that it should be able to do.
True. Definitely. But you still have the performance impact, right? Yeah. True that.
So you still can ask Thilo afterwards, so while networking. And with this, the official part is over, and basically drink, talk, whatever. Thanks.
Thank you. Christina, Dankeschön.
Awesome. Ja, cooler Talk.
Oh, merci. Aber ich war viel zu schnell, habe ich gesehen, oder?
Nein, super.
Ja.
Also wenn ihr noch mehr habt, wir sind immer happy, euch zu haben.
Ja, ja, wir haben noch ein paar Projekte, ja. Muss
Ja,
nur
es
schauen,
geht
ob wir die anderen überzeugen können, einen Talk zu machen. Das ist das Problem.
Ja, weil das ist genau diese Insights. Weißt du?
Ja.
Weil jeder
Das finde ich auch am spannendsten an den Talks, ja, von an, wie sie es benutzen, oder?
Genau.
Ja.
Das ist nämlich gerade das Coole. Wir machen andere
Ja,
Problemix.
definitiv, oder? Hier kann ich einfach rausschreiben, oder?
Ja, kannst du einfach rausschreiben.
Ja.
Wie seid ihr denn?
Ja.